Hello, guys. Good evening, everyone. Good evening, everyone. Welcome to another episode of Xah Talk Show. We are going to code Wolfram Language. Wolfram Language, also known as Mathematica. So we are going to code graphics programming animation. We are going to create this animation. If you are here, say hi. Love to see your comments. If you are watching this offline, play at 1.5 speed. Okay, so we're just gonna code that, and let's begin Wolfram language. Cheers, red wine. There is Wolfram language. Start a new notebook. Okay, 3 shift enter to evaluate to start the kernel, and magnify 150. Okay, so we're gonna draw this animation. So let me just show you directly. I have already written the code like about 30 years ago. So it's just updating so that I can, hold on a second, show you. Okay, so if you want to know, if you want to get the code, you can already do so. Just search for Wolfram Xah Lee, my name, Xah plane curve generator package. Okay, so you can search for Xah Lee Wolfram language packages. And one of them is Wolfram plane curve generator package. So this package, you can download it on GitHub. It will generate about 30 animations that illustrates the definition of plane curves, many special well-known plane curves. So for example, one of them is this one we're gonna do today, asteroid generator. And asteroid can be generated in several ways. One of the definitive way by definition is you roll a circle inside another circle. The circle is 4 times smaller in radius. So we can show you, so you can see, so this package, so this is another way to generate asteroid. So asteroid is a curve that looks like this. Okay, so this is an animation generated by that package, one of the way to generate asteroid. And you can also generate it by rolling a larger circle. In fact, these two methods, they sync together. Very interesting. Okay, that's because of the mathematical properties. Also, this curve is also known as a toy called spirograph. If you search for spirograph, you'll find lots of Spirograph. I think it was trademarked. So there's a Wikipedia article, and let's go to images. You can see lots of this toy. In fact, I happened to have this toy when I was like 8 years old or 10 in Taiwan. So that was like 40 years ago. So yeah, so spirograph, fascinating. So anyway, so the curve, the asteroid is one of the spirograph, okay? So anyway, so this package generates all these animations. You can download for free. That's Wolfram language. And so another way to generate the asteroid is by the ellipses. So these ellipses, they share the they are confocal. They share the focus, and they share. I think the sum of their circumference is equal. Was that right, or something I forgot? But you can look up. So go to asteroid. So you can find my website. This is called Visual Dictionary of Special Plane Curves. This is one of my earliest project that made my website popular back in 1997, up to 1997. So you search for that website, Visual Dictionary of Spatial Plane Curves, and you just search for asteroid, one of them here, asteroid. So you can find this page, and then you can find this animation, and then properties, then by the way, this mechanism, this way of a bar fixed onto two perpendicular bars, you slide the bar around. This mechanism is called a tremor of Archimedes. So anyway, so asteroid is an envelope of coaxial ellipses whose sum of major and minor axis is constant. I see. Major and minor axis. I see. So you know, the major and minor axis, which is basically the length of the ellipse and the width. Use sum them together. Did I define it here? Major axis is a line segment passing the foci and intersect with the ellipse. Yeah, so that's basically the width. Minor axis is a line segment perpendicular to the major axis, passing the center of foci and intersect. Yeah. Anyway, kind of like the width and height of the ellipse. So if they are all constant, you know, then you draw all of them ellipses, then they form, their envelope is the asteroid. So anyway, that's an asteroid. Okay, lots of very interesting properties. Okay, now let's start to code. I want to generate the code for that graph. So the code. So today we're gonna focus on coding. Okay. So Wolfram Language coding. So you want to go to Asteroid and okay, let me think about what to do. So if you here, say hi. Okay, love to see your comments. Okay, let's get to code. So what I want to do is I already have the package. So let's go to Git generate. So this plane curve generator package. So here is the source code. You can see here's the source code started in 1995. 1,500 lines of code. So all these are Wolfram language code. Okay, those are documentation, and here's the code. So okay, so let's see what we're gonna do. Asteroid. So there are 3 functions to generate asteroid. I think we're gonna do all of them. So but let's do them one at a time. So copy that. So what we're gonna do, asteroid generator. So let's create a new file. So should we save the file here? Why not? Okay. Asteroid generator .wl. Okay. So okay, so we copied that, and okay, so why don't we copy 1, 2, 3 asteroid generator 1, 2, 3. Okay, so paste it there. Delete the duplicate. Okay, go back. Then you want to actually find the code. Okay, so we start to have the code here. So here, starting the code. Okay, asteroid generator. Okay, and generator 2 and generator 3. Okay, so let's copy it, close it, and paste it here. And instead of separating them, let's put them together. So let me do this. So here's the options, asteroid generator, and so one. So here's the asteroid generator, and there is a code. Then there's asteroid generator 2, okay, which is just basically based on, oh Jesus, there's a dependency. It depends on hypotrochoid generator, you see. So that's not what we want. we want them to be independent. So let me just do some work. Okay, so wait, new one. So let's save this Asteroid Generator 2 Wolfram Language code and delete. Okay, okay, and delete that. New page. This will be Asteroid Generator 3 dot WL. Okay, so the generator 2 3, so 3 and 3 copy. Okay, 3. So there. So this is asteroid generator number 3. What does number 3 does? It does plane curve generator. So this is the number 1 by Trammell. Number 2 is rolling a circle, small circle, 4 times smaller. Number 3 is by this ellipses whose sum of major and minor axes are equal. Okay, so yeah, so it's documented here, showing that it's envelope of coaxial ellipses whose WHOSE, spelling error, HOSE, WHOSE. Okay, so I got this. So let's replace all WHOSE by ES by SE. Okay, can we like replace all? Okay, it occurred there. Okay, so anyway, asteroid generator 3 is coaxial ellipses whose sum of major and minor axis is constant, are constant. Okay, anyway, special option. So this is generator 3. It's independent code. Is that right? Yes. So asteroid generator 2 is, it depends on this hypotrachoid. Okay. And asteroid generator 1, refresh. Where's asteroid generator 1? Okay, so delete that. So here's the code. Okay, so actually we can start to run it. Copy it. Okay, select all, paste it, shift enter. It's defined. Is there any error? No error. Okay, in fact, we can just shift enter control shift N to make it typeset. So you got fractions there. Okay, it's not many parts can be typeset. Anyway, so that's a code. Then you can read the asteroid. So this is the documentation. This is how you define documentation, inline documentation string in Wolfram language. Okay, now there's something I don't like. Well, you see, when you copy this and paste it to Wolfram, they become \n. They auto convert to \n. I'm not sure I like it. Like shift enter. Okay, now when you press shift enter N to typeset, then it become \n. Okay, otherwise it's literal, the new line character. Okay, so anyway, so here is so that's so we can type question mark. That will give you the usage string. So the question mark is actually information. Okay, information. You can also do it this way. Okay, that's equivalent. So the question mark is actually just a shortcut for the information function. Well, not exactly. But okay, we are digressing. Let's go back. Let me just code. Let me just show an example. Okay, so let's see. Oh, well, you have to do, actually, you don't have to say any parameters, just empty. Okay, Astro generated that. Shift enter. So now it generates a list of graphics. You see, fantastic and beautiful. Now, if you want animation, you just say list animate. So you just say list animate. Okay, that will take a list of graphics and creates an animation out of it. Shift enter. So there we have it. Cheers. Okay, what I want to do, so go back to my website. I wanted to replace, let's see what I want to do. I want to add the independent code to the page. So this is Asteroid page. So go down, go down, go down. I want to add properties. Okay, I want to add a code right here so that people don't have to like download the package. When people, look at my visual dictionary of plane curves, they can just copy the code right here, and paste in Wolfram language, and they can generate the animation without having to like download my Wolfram packages, find the link somewhere. So anyway, so the code is just here. So it's like, 50 lines of code, actually 20 lines. But okay, so here's the full code. So actually, for example, copy it. Let's go to this page. Okay, copy it, go to talk show. Today's talk show, that showing browser, back, search for asteroid, there, go to it. Then tremor. Okay, so tremor here, you can just say start a Wolfram language code, paste the code here, syntax color it, press, syntax color it. You can see that was Xah HTML, re-HTML pre-code buffer. Okay, showing browser. Page down, 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 and scroll down so you can see here's a tremor of Archimedes. And here's a code, Wolfram language code, so people can copy it and, it'll run. So, but, okay, so does that make sense? Is that, yeah, I can, because I'm thinking about, so in the future, I'm gonna have lots of this code. You probably want, if you are going to add the Wolfram language code to the web page, some of them are fairly long. In fact, so if you're gonna have a lot of code, you probably want some kind of compact feature. So you press a button to hide all the Wolfram language code. Yeah, that's so this is regarding user interface design. So that's probably something I want to do. I need to do, you see. So again, we are doing this educational, like online book, visual dictionary of spatial plane curves. Each one shows the properties. Hold on a second. Hold on a second. My wife is back, so I'll be back in 2 minutes. Okay, I will be back in 2 minutes. Okay, hello guys, I'm back. So turn on the video, turn on the camera again, check video, check audio, check am I back and alive. So my wife is back, so I'm gonna have dinner soon, but we can continue. So I'm working on updating my this project, Visual Dictionary of Spatial Plane Curves. So you go to Asteroid, you need to update all these graphics, but now you included this. We did this live stream like a year ago, so we updated the video, you see. So showing browser, so we updated. Now we are trying to include the code so people can generate the animation themselves. But okay, so what's the next thing to do? The next thing to do is that first there are a few things to do. Okay, one thing is that hello ACP, good morning, good evening. Where you from, ACP? I forgot. So we are going to, there are a few things we need to do. Okay, we are going to possibly optimize this code, because this code has been written like literally 30 years ago. Okay, so let me go to it. So so this code, we're gonna possibly optimize it. Okay, we'll have to see, rewrite, or maybe just change the coding style, because after 30 years now I know quite a lot more about programming. We might optimize the code, but typically my code is pretty efficient. We are just gonna optimize in some, possibly, but usually my code is pretty efficient even back then. So that's one thing to do. The other thing is to look into the possible formats for the animation. You see right here. Let's search for tremor. Okay, right here it's actually using a. We did this like last year live. It's using a WebP format. You see. Open it. That's like a WebP animation. So WebP is a image format, but it also allows animation just like GIF. So it is actually not a not a video format properly, but yeah, I mean it can have a video. So it's interesting situation. So so this is all done by Wolfram Language. So let me show you. We need to show it. Okay, list animate. So let's say XX equals 2. Okay, done. Then we say export. Export. What is the syntax? Export file name and expression. Okay, so file name. Let's do that in yeah. Okay, so export file name xx dot web. What is that file format? WebP. WEBP. That is a image format from Google about 10 years ago. Google invented it. Okay, the expression is just XX. So export to WebP format animation. Okay, XX is this animation. Okay, so it's gonna take a while. It's not done yet, and we also gonna do MP4. Okay, we're gonna wait for it. Okay, that is done. Now let's do the MP4. It's interesting because the WebP is a image format, but it also supports animation. Done. Okay, now let's go to documents. By default, they are saved in documents. So there they are. So you can see there's a huge file size difference. Oh, you see, why? Why did I do WebP? Because WebP is 3 times larger. Amazing. So wait, copy the file path for both of them. Now go to here and paste it and linkify that and linkify that. You see, one is video. It became a HTML video tag. The other one is the image tag. Okay, now let's check this WebP. What size is it? So wait, so open it. So this is 600 kilobytes. You see, one is 600 kilobyte. The other one is like 200 kilobyte. Okay, so the WebP is 600 kilobyte. And what about this one? So let's look at this one is 500 kilobyte. Okay, wow. Okay, now you're gonna show in browser, show them all. So let's go look at so this is about like file format issue. Like when you write a tutorial, you have to also you have to worry about the code efficiency to generate the animation, but you also have to worry about like which format should you use, and also browser compatibility, like which version, which format, video format browser supports. You see, so this is MP4. I like this the best. Okay, I like this the best because okay, then it includes that this thing we may not want it. You see, we may not want that. So this is WebP. You see, this is WebP. Let's say that's the name. Okay. Now actually, let's rename them. First of all, move them into the current directory. Okay. So I have a command in Emacs. Do it. Wait. Do it. Okay. Save it here. Now save it in this current directory, and you're gonna name them as Tramo WebP. Okay, and you're gonna rename them as Tramo MP4. Okay, and okay, so actually let me just do this. Okay, so yeah, so these two, we have two WebP versions. So look at this. So this WebP is 600 megabytes, 600 kilobytes. Okay, what about this WebP? This WebP is 542 kilobytes. Okay, now you see the difference is that one of them got this Wolfram language control things. We don't want that usually, so we need to fix it. So there are several issues. First of all, which one you gonna use? I'm gonna use MP4. I'm pretty sure I want the MP4 format. I don't want the WebP because it's 3 times larger, the file size. Now the other thing is that we don't want this we don't want these bars on top. So so actually you just all you have to do is you just export that. Okay, there it is. Okay, MP4. So now let's go to documents again, XX MP4, open it. Fantastic and beautiful. Okay, so copy the file path, close it. Now paste it, linkify it, move it to the current directory and rename it asteroid tremor. Yeah, just random character there. Okay, copy it and relink it. Okay, so that we got the proper figure caption. Okay, delete that. Now open this MP4, delete it, delete that. Open this WebP, delete it. Open this WebP, delete the file, and delete that. And now show in browser. So now page down, 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 page down. So we got this MP4 version. That's what I want. Now there is one more thing. You see this video MP4 it doesn't show the, for example, refresh. It doesn't, you want a poster to show like the middle of the frame so you can get an overview. So you want a poster. So in order to do that, you can save this, you want a poster like that. Okay, so for example, let's say before it finishes, something like that. Okay, so you want a poster. So you can kind of, let's say not that one. Almost like this one. That's what you want. Okay. So you can like save this, convert to canvas, paste, cut graphics, copy graphics, make hyperlink, save graphics as. Okay. Not PDF. We hate PDF. We want PNG. Okay, so let's just say, save graphics as. In fact, it would be better if you just do a screenshot. So let's do a screenshot. Okay, so wait. Do a screenshot. Wait. Okay, do a screenshot. Okay, there it is. And now move the screenshot here, open it. That's the one. Okay, now rename it that. Okay. Okay, I don't like that. Rename it. Okay, now relink it. So that is that's the file path. You want to say a poster. Okay, so you add, so shift, so you need to do, am I making sense? live in South California. Fantastic. The open video container is WebM. Oh, really? Okay. So so anyway, let's do this. So we got yeah, so we want to tab A. So you want to say wait, poster, okay? Poster there, okay? Delete that. Now go back to the browser, and if you refresh, it will show a poster. Like refresh, you see, fantastic. Now play. That's what I want. That's what I want. And people can like do a loop if they want, and there should be a back and forth speed play loop. You know, I wish there is a like right click back and forth. Anyway, so that is a video. That's what we want. Okay. So the open video container is WebM. Okay, so you are talking about, is that right? The WebM Wikipedia. WebM is a audiovisual media file format. It is primarily intended to offer a royalty-free alternative to use in HTML video and HTML audio elements. It has a sister project for images, WebP. Okay, the web development of the format is sponsored by Google and blah, blah, blah. Yeah, okay, I don't remember the details, but you know, WebP by now is like pretty old, but to me it's like still yesterday, because why the fuck Google created a new image format, you know? And today, the better image format is actually XJPEG. Okay, that's called JPEG something, you know. There's also JPEG 2000, you know. And also another one is AVIF, I think. Anyway, image format, there's a big fight, you know, big image format war. And we discussed on Xah Lee Discord, but I don't have Discord on, so let's not open it. Anyway, so yeah, the image format is like, okay, let me show you, why not? AVIF, that's a new latest image format. AVIF, which I think is very good. The other one is called JPEG. It's called XJPEG. Okay, let's just search for XJPEG. XJG. No. JPEG XL. Yeah, that's the one. So let me tell you guys about this, okay? So image format technology, they are apparently still improving. So it's not like, you know, you thought, you know, you learned all the technical details about JPEG and PNG and how they what's their difference and GIF, you know everything about it. But apparently every few years the technology changes. You know, like the JavaScript and the HTML, the DOM, it changes. It just like keep changing. CSS, you know, you thought we had everything we needed. You know, like you mastered the whole programming language, JavaScript and CSS and HTML, but actually they keep changing for reasons. You know, some of the reason is actually valid, you know, because society, you know, because things change, you know, therefore we need, you know, corresponding changes to progress in technology. Programming languages, you know, they change, right? So some of the change are natural and needed. Okay, but actually, here's the thing: some of the changes are not natural and not needed. They are created because for political reasons, like some nasty organization, for they want money and they have the power. They made a change. So many of the changes in technology are that nature. Okay, that this is a interesting thing I'm telling you guys from my experience. Okay, so anyway, let's go back to the image format. So image format, they are also changing. So apparently, so the latest two primary contenders are the AVIF image format and the JPEG XL. Both of them are, first of all, of course, much more efficient than the standard JPEG that we know of. The JPEG or, for example, JPEG or PNG, the image format that we are used to. The two major standards are JPEG, PNG, and GIF. GIF is like variation, it's like obsolete, but people still use it. GIF is like really, really bad. Very inefficient, okay, but it was like 30 years ago, it's most popular. So anyway, the most popular image format today is JPEG and PNG and Google's WebP, like WebP from 10 years ago. It's like it's not so as much as popular as JPEG. The dominant like 90%, 99% of the web is JPEG, and the other maybe 1% is PNG. Then the other like 0.1% is WebP. Okay, that's the situation. In fact, we can ask Guac to give us a that would be interesting question. Oh, I don't have my Twitter on. We can ask Guac to give us my Twitter. So tell us the distribution of JPEG and PNG and GIF and WebP used on websites. So let Guac give us a sense of how these formats are used on the web. Let's magnify the page. Okay, as of February 2026, the most reliable and up-to-date source for the distribution of image formats used on websites came from W3Text, which tracks usage across millions of sites. Okay, PNG, what? 97% of website. What? Wow, I'm surprised by that. PNG 77%. I don't think that's true. What? JPEG is 72%. I think JPEG is much more popular than PNG. But PNG is 70%. What? This is interesting. This needs more further research. Okay. And WebP is 20% of websites. Wow, that's amazing. I think mostly, what? Amazing. Okay, but very interesting statistics. Okay. Anyway, so what I'm telling you guys is like AVIF is the latest and JPEG XL. Okay. Anyway, we digressed a lot. We should go back to Wolfram language because that's what we are doing today. So Asteroid, let's go back to Wolfram language. Asteroid page, we did this. Okay, this is what we want. Web MP4, that's what we want, and we got the code. Now the next thing, let's optimize the code. Okay, we were going to do the others. We were going to also do this one and this one, but we don't have time. So let's now let's see. Can we optimize the code? Yeah, why not? So let's do that. Okay. Number of frames. Do we have still that number of frames? Yeah, we do. That's an option. So this is how you code option in Wolfram language. Okay. This is how you this section is how you code option. How you define optional parameters of a function in Wolfram language. This is how you define it. So in our case, we support the special option number of frames plus all the options in the graphics. So for example, we can change our code coding style using the @ sign. Let's do that. So join, yeah, we can. Let's make it one line. Okay. Well, same thing. Okay. So anyway, so options. So let's see the documentation. Other options are passed to graphics. Okay. So T means, so this is so this is another way to call the function. T mean greater than 0. Can you use like that? I wonder what Wolfram can interpret this expression using with Unicode. Let's try. Oh, Wolfram can. So let's do that. So yeah. Wait, that's not what you want. Oh God. Actually, so wait. Okay, I need to, you see, I want this to become the less or equal to symbol of Unicode. So I have a command to do that, which is this command, which is Xah math input change to symbol. But right now, if you do it, it's not working because it changed the less than sign to this precede symbol. You see, this symbol is called precedes. Okay, it looks like a less than sign, but it's got curves. Okay, but what I actually want is not that. Wait, undo. What I want is the less than or equal. So let's fix my Emacs code. So we are doing multi-code, Wolfram language and Emacs Lisp. So let's go to describe function. Press that key. Xah math input change to symbol. So let's go there. So this is a package about 1000 lines. Okay, undo. Now let's search for equal, less than. Search for that symbol. Not found. Now let's search for equal, greater than. Okay, and then you find it. So let's jump there. Okay, that's not what we want. So wait. Okay, wait, not here. So go back. Okay, go back. So search for that symbol. Okay, go to the code. Least matching lines. Search for that. So you got. Okay, so you see. Oh, I see. What? So so this is bad. Okay, so that should be if you do that, that works. Okay, so but what is that the least function even? You see, this is what I want, okay? But why did I type that? Do you guys follow me? So Emacs by default doesn't support AVIF. Is that true? Yeah, probably. Well, because GNU stuff, open source, they are always late. They're gonna wait for like 2-3 years or 5 years even. That's true. If you want AVIF supporting Emacs, you're gonna wait for like several years. That's always true for open source stuff. On the other hand, for commercial stuff like Wolfram Language or like let's say Google Chrome browser or the Firefox, well, not so much Firefox. Firefox became like very deep state. Anyway, anything commercial where you have to pay, they support it right away, of course. But then if you want to, the open source like free things to support it, you have to wait. Anyway, so we are looking into like esoteric details. You guys probably don't know what I'm doing, so this is the thing I'm looking into. So what programming language support this thing? I forgot. Why did I write that 30 years ago? Let's see. Python operators, we want to look for the less than equal. So what was the Python syntax for less than equal? So operators assignment, true, false, Boolean operators. Let's see. Boolean operators, okay, they use words in Python. Test equality, test order, less than, okay. So Python, it's, okay, so it's like less than equal, okay. So Python is using that, okay. So this is what Python use. I'm wondering why did I type that? So let's see. Is that Wolfram language? No, that's not even Wolfram language. So less than equals to, oh yeah, so in Wolfram language actually, for example, 3 less than equal, you just type less than and equal, it automatically become that. You see, all you have to do is type less than and type equal. It automatically changes to that, you see. So I don't know how did I get this 30 years ago. It's a typo, probably a typo. So anyway, so let's do that. Okay. So you are saying that asteroid generator T-min, T-max, T-step can also be used, and T-min greater than 0, T-max less than 2 pi, okay? So C rows generator for detail. Oh my God, I don't want that. So that's about, so that's a documentation. I did this documentation 30 years ago. So in general, you don't want, look up the other function for detail. You don't want that. You want just whatever detail, just like repeat it here. Anyway, so this is about documentation, inline documentation. So what is a rows generator? So let's look at search for okay, search for rows generator. Okay, so you got this rows generator. Okay, what detail? So C rows generator for detail. Oh God, there's a lot of them referring to it. Okay, so finally here, rows generator and generates tmin tmax rows generator also used tmin and tmax control whether the animation will trace out a complete rows. Okay. Anyway, I don't want to worry about this now. So okay, so let's see what. Yeah, you don't want that. Okay, so let's just say that. Okay, actually, oh god, we were supposed to optimize this, but we already talked for an hour, so yeah. Okay, so this code, yeah, we really should be working on the code because that would be most interesting to me though is to optimize the code. But now we already, I think we already like randomly chatted for so long. Anyway, so okay, can we do this? Okay, so let's see. So we got the code. God. Okay, so let's do the code again. Okay, you need to work on the code. How long have we been talking? We've been talking for just 1 hour. Okay. So now, what about the code? Go up. Yeah, here's the code. Okay, so God. Yeah, actually, the code is what we should be focusing on today. But okay, so you see the way it works, it's pretty simple. So if you do not give any parameters, it basically assumes from 0 to 2 pi, I think. It basically calls, you see here. So the first argument will be 0 to 2 pi. The second argument would be optional pattern. What is this? Basically 41, number of frames 41. So then we start to code number of frames equals to optional value number of frames, which is 41. Okay. Then we started to min, tmax, tstep equals to, so this module part, those are local variables, I should be changing them to block because the module is very slow. So tmin, tmax, tstep are 3 values. We set them to be tmin equals to range, trange. Okay, so if that range is 3, what? Yeah, so I think there's a lot I want to change. Okay, I think maybe we shut down today because right now I'm not. Right now I cannot code because I had this 200 ml of red wine, and so we want to possibly improve the code. That's what we are doing now. Okay, and in order to do that, so we are starting to code geometry of this thing. Geometry is pretty simple. So you move. So you basically, in each frame, you want to change the position of the two endpoints of the line. Okay. So that line segment and that would be just cosine and sine. Okay, you see. Yeah, so the endpoints, basically the coordinate x and y for the endpoints of this line segment, they are just cosine 0 and sine 0. Okay, that's the point. That's so simple. Okay, so in each frame, you want to it's so simple. Okay, so but this code, there's a lot. Yes, there should be a lot to change because, for example, the hue 0.75, we can change to like blue, the symbol blue. And last frame, okay. Yeah, definitely I want to make some changes to the code. Okay. Showing browser. So, by the way, my website has not been updated for the past 20 days because I'm having some issue of rsync. So I was unable to update my website for the past 20 days for technical problems. But I'll be able to fix that. So what that means is right now, whatever I updated, whatever I updated to my website today, you won't be able to see it. When you visit, my website, you'll see like the old page, not whatever I did today. So anyway, so you won't be able to, in other words, you won't be able to see this code. But anyway, but you can get the code, of course, because the code is from my plane curve. Just search for it, the package, you can get the whole code. Okay. Anyway, but this should be fixed in a few days. I'm gonna fix it. You'll be fixed eventually. So anyway, what's for today? So let's summarize. So today we updated this and we created the code here. And we should have yeah, the code is not too long. and you should have okay, I think that's it for today. So I think what am I doing? So I need to also need the code for this and code for that. And we want the web 4 version. We want the MP4 version. We don't want WebP. Okay, so I'm gonna do that offline. And okay, I think that's it. Yeah, so I don't think anyone is watching. So bye, guys. Okay, so let me think about. So we did that. We don't need cardioid. We don't need envelope. We only did the asteroid. And okay, so close that. We want to. So this is a generator package, and shift enter. So refresh. So we also have search for asteroid. So asteroid 2 generator. So asteroid 2 depends on the hypotrachoid. Jesus. Yeah, I don't want that. Okay, so then what about the asteroid 3? So asteroid 3 is independent, I think. Let's try it. Paste. Wait, can you paste it? Shift enter. Okay, then you just need to say asteroid generator 3. Now question mark to show the documentation. So you don't need any parameters. So let's run it. For the function, shift enter. Okay, so it's generated a bunch of graphics, but you want animation, so you need to say list animate. Okay. Fantastic. Now let's generate a copy that. So now export. Let's export again. Export that thing. Shift enter. Great. So now let's go to go to the documents directory, search for xx dot. That should be that latest. There it is. Open it. Okay, run it. God, stupid. You know, this VLC player always have this problem. When you play it, after it finished, it just like it goes to this page. Like you click play again, it goes to that stupid page. Okay, so copy the file path, close it. The asteroid generator 3, that's right. So close it. Now you want to go to the asteroid page. It's asteroid page. So that would be the asteroid there, and the ellipses. Okay, so go back, search for ELLIP. Okay, so this is where you want the code to be. Paste the code. Wait. Paste again. Wait. Wait. Okay, so that's animation. Now this asteroid by ellipse. Oh wait, so in this example, what? Permission denied. Oh Jesus, because it's open here. Okay, move to the current directory. Okay, then copy extract the URL, paste the URL, make a link, and delete the previous one. Okay, so that way we updated the figure caption. Okay, so now refresh. You got this animation, which you don't really need because this. Okay, so we don't want the animation. Open it. Show in browser. I mean, show. It's 55 kilobytes. Okay, so question is, do you want it? I don't think so because as a design principle, when you have some graphics, you know, the issue about animation is that you want to show an animation only when it is fitting. You do not want to show everything by an animation. So, for example, in this illustration, to illustrate the property of this asteroid, which is a envelope of coaxial ellipses whose sum of major and minor axis is constant. You do not need an animation for this. If you do with an animation, it's kind of redundant. You know, it's kind of so the optimal design for this page is not to have animation. Okay, that's what I think. So okay, so wait, so let's delete that. So but there's a question about, so then, but you do need the code though. You do need the code to show this illustration. Wait, so actually, so you do need the code. So The code is here. Okay, so you kind of so you can add the code there. Syntax correct, showing browser. Okay, so here is the code for that kind of overkill. Because the code is actually trying to generate an animation. But you can give a parameter so that number of frames equals to like 2. So it doesn't generate the intermediate frames. It generates. But anyway, but you should actually you should modify the code so that it just generate an image. Well, maybe not, because you see this code right now is generates an animation, which is kind of necessary, because when you have this kind of envelope of a set of curves, sometimes you want to show them progressively. So in other words, even though this property can be shown as one single static graphics, but sometimes it is necessary. I mean, sometimes it's helpful when you show this as an animation of progressive number of curves that forms the envelope of a new curve. So therefore, that's what this code is for. This code generates that animation. It can generate the final animation, just 1 frame or 2 frames, beginning and end. Or it can generate, 10 frames or 100 frames for refined animation. So why don't we just show it? So for example, let's call it, copy it. Okay, so let's call it. So you need to say what is the min max and step. Okay, so you can say min is 0, max is 2 pi, and step, let's say pi. That will be like 3 frames, I think. Oh, wait, that didn't work. What? What did we Asteroid generator 3? What? Wait, I thought so there is a oh, so it doesn't take a step. What? Wait, that's strange. Okay, so there is some problem. No, this is not correct. Okay, so that works, but as soon as you give it some value, it stops working. So we need to fix that. Okay, so that is not correct. Oh, you need to yeah, you need to put them inside brackets. That's why. Okay, so you need to put them inside brackets. That's right. So 0 to 2 pi in increment of pi there. There it is. So it generates 3 frames. Amazing. All of them doesn't look right. So in increment of, let's say 2 pi, let's see what you get. Nothing. That's not. Let's say in increment of pi divided by 4, let's say. Okay, so this is incorrect code. Oh, Jesus. This is actually incorrect code. I didn't realize. Formatting notebook content. Okay, I think. Okay, so this is incorrect code. So we discovered a problem. Anyway, that's it for today. Thank you guys for watching. Bye, guys.